Okay, Paul, tell us what you're going to show us
So,
here.
I'm going to show you a complete self-priming with the A-series Mouvex eccentric disc pump here.
Okay.
And we're actually taking the liquid from an underground tank and up to a lift which is, let's say, 4 meters, which is more or less 12, 13 feet.
Okay.
So I'm not going to start the pump.
Okay.
So of course here the pump, as you may see on the...
It's not very loud. It's not a really loud.
No, it's a quiet operation.
That's good.
So we can see on the panel, you see a top right, we've got a suction pressure. We can see that the pump is creating vacuum. We have a negative pressure. Just to show you how strong can be the vacuum of this pump, just to show you I'm closing the valve and suction of that pump and see how quick the vacuum increases. So we have a vacuum here of minus 0.9 bar, which is equivalent to something like, I would say 26, 27 feet of vacuum, which is really strong.
What are we looking at? Are we looking at the liquid right there in the tube?
So here in the pipe,
okay,
the smaller pipe, and here is the liquid coming just by the effect of the vacuum of the pump. So by slowing down the pump, I can control perfectly the vacuum. See here I've slowed down the pump, so I can even keep the level constant just by controlling with the vacuum. It shows you how tight is this pump inside, how reduced are the internal leakages.
And what is the viscosity of this liquid? What would...
I would say it's not very viscous. It's around, let's say, it's less than 100 centipoise.
Okay, so what kind of, like, give me an example of what kind of liquid we're talking about here.
And centipoise, it can be some kind of oil, either vegetable oil or mineral oil.
Okay.
This is actually a mineral oil which is in that system.
Okay, so now I see it's filling up here.
So you see now it's up there. At the more it will go up to the mark 4 meters, which are approximately 12, 13 feet.
Okay.
You see once again just by controlling the speed of the pump, I can control exactly the vacuum I'm creating.
Now, are you controlling it manually?
Yeah, with a variable frequency drive.
Okay.
Here.
Okay. So is this something that an operator would control, or is this controlled
Well, it's just
remotely?
that on a customer facility, they just have to incorporate a variable frequency drive if they feel they're going to need it. Right, so we carry on lifting the liquid. So we're passing up the highest point of the loop, and now we are going down back to the pump.
Why is it important for it to lift up and then come back down?
So, well, actually, it shows something that shouldn't be done on the field, but that's for the example.
Okay.
Having a high point like this on a pumping installation, generally, one of the issues is that you keep an air pocket in your pipe. Right? And, well, if you are transferring diesel or oil, it's not a big issue. But if you are transferring an emulsion-sensitive liquid, that can become a problem.
Okay.
So, of course, in some cases you have no choice. You've got to go over a wall or something. So, you have no choice on the field. You have to do the obstruction like this. This is just to show something that shouldn't be done.
Okay.
But this is a teaching installation.
Sometimes bad examples are good examples, right? So you're turning it up?
So yes, I'm accelerating the pump a little bit. The next step you're going to see is how the pump is able to strip the lines from the remaining liquid.
Okay.
So it just needs a bit of time to finishing emptying the tank which is outside. So what we can see while the pump is in progress emptying, I propose that we move on this discharge side.
Okay.
One of the characteristics of Mouvex pump is to show a constant flow rate, whatever the discharge pressure is. For instance, here we have a 0.8 bar discharge pressure, which is approximately 10 psi. And we have a 4 cubic meters per hour flow rate, should be something like 15 gallons per minute. And we are discharging through that straight 2-inch pipe here.
Okay.
What I'm going to do now is I'm going to divert the flow in a twice smaller pipe, 1 inch, much longer and full of pipe ends.
Okay.
Let's see what happens. We may see that I have more than double my discharge pressure. In spite of that, my flow rate remains constant.
Ah.
So that's a key characteristic of Mouvex pump. You get a constant flow rate, whatever the discharge pressure is, whatever the viscosity is, and as we already saw, whatever the wear of the pump is.